Welcome back students to the third session of today. In this module, let us discuss about a few optical instruments and about microscopes and their magnifying power. Optical instruments are instruments which work on the property of light. A few optical instruments that we are going to discuss here are microscopes and telescopes. So in the beginning, let us discuss about a simple microscope. A microscope is an optical instrument which forms a large image of a close and minute object. This image subtends a large visual angle at the eye so that the object looks large. In the simplest form, a simple microscope or magnifying glass is just a thin short focus convex lens carrying handle. The object to be seen is placed between the lens and its focus, and the eye is placed just behind the lens. Then the eye sees a magnified, erect and virtual image on the same side as the object. The position of the object between the lens and its focus is so adjusted that the image is formed at the least distance of distinct vision from the eye. The image is then seen most distinctly. The magnifying power of a simple microscope is given by m is equivalent to 1 plus d by f. Here m represents magnifying power, capital D represents least distance of distinct vision or the near point of the eye, and f represents the focal length of the convex lens. If u is equivalent to f, then magnifying power m is equivalent to d by f. The magnifying glass is used by watchmakers and jewelers to have magnified view of tiny components of watches and fine work on jewelry. It is also used to examine fingerprints and palm lines and by the students to read vernier scales, etc. This figure shows us how to calculate the angular magnification. Here, theta I is the angle subtended by the image, and if theta O represents the angle subtended by the object, then angular magnification is given by angle subtended by the image divided by angle subtended by the object. Now let us discuss about a compound microscope. It consists of a long cylindrical metallic tube carrying at one end an achromatic convex lens of small focal length and small aperture. This lens is called the objective lens. At the other end of the tube is fitted a smaller tube. At the outer end of this smaller tube is fitted an achromatic convex lens whose focal length and aperture are larger than that of the objective lens. This lens is towards the eye and is called the eyepiece. Cross wires are mounted at the focus of the eyepiece. The entire tube can be moved forward and backward by rack and pinion arrangement. This is the ray diagram representation for the image formation by a compound microscope. Here, the objective lens and eyepiece are shown to you. Objective must be a lens of smaller focal length, and eyepiece must be a lens of larger focal length. Object is marked as AB, which is at a distance u from the objective lens. The image formed by the objective lens is A dash B dash, and the final image formed by the eyepiece is A double dash B double dash. The final image will be formed at the least distance of distinct vision, capital D. The final image will be inverted. FO and FE represents the focal length of objective and eyepiece respectively. H represents the size of the object. H dash represents the size of image formed by the objective. When the final image is formed at the least distance of distinct vision, then magnifying power of a compound microscope is given by minus V0 by U0 into 1 plus D by Fe. When the final image is formed at infinity, magnifying power M is given by minus V0 by U0 into D by Fe. In order to increase the magnifying power of a microscope, U0 should be small. That is, the object should be placed quite close to the objective. But to obtain a real magnified image of the object should be placed beyond the focal length FO of the objective. Hence, for greater magnifying power of the microscope, the focal length of the objective should be small. The distance VO of the image from the objective should be large. For this, the object should be placed near the first focus of the objective. The focal length FE of the eyepiece should be small. We have already discussed that magnifying power of the combination M will be equivalent to the product of the individual magnifications. That is, M is equivalent to ME into MO. Here, ME and MO are the individual magnifying powers of objective and the eyepiece lens. Magnifying power M is equivalent to VO by UO into 1 plus D by FE when the final image is at the near point, and magnifying power M is equivalent to VO by UO into D by FE when the image is at infinity. Hope you might have got an idea about simple microscope, compound microscope and its magnifying power. Thank you, dears.